looking for a solution to silence?
Wall Street. I revealed this.
804. Did that go far?
Coming in. Yep.
In bags and
Very smoothly.
535 98. Another.
800, 500.
Well, yeah, that's the point. I would ship a tooth.
Complex. Even though your phone can perform all the same.
You said, Cap.
Yeah, I was going to make a comment on your 10 meters. I wonder if you've done right at the house.
Wind 140 at 12.
Okay, we made some progress with this thing. It's alive all right, and not perfect. We've got some issues. We haven't got the AGC figured out. We've got this raucous hum that we've got to take care of. But I have not touched one trimmer. I have not touched one variable capacitor on this set. It is as it came to me. And that's pretty amazing that the LO works on all bands and that the BFO functions at all. I was really worried about the BFO and that I'd have to go into this cavity and play with the BFO, but so far so good. Got a lot to cover in this one, and we haven't talked about the magic eye at all. We haven't talked about alignment and about tubes and tube substitution. We've got quite a bit to do in this video, and I think we have a living patient. We've got a power supply speaker unit now. This is going to be interesting to go through the construction of this unit. So let's talk a little bit about power supplies. We're going to need to collect some parts to build the power supply for the 1150. We're going to need a power transformer that's got a high voltage secondary as well as a 6.3 volt filament. We're going to need a small choke for filtering, some 47 microfarad 450 volt electrolytics, small speaker of some kind, some terminal strips, on-off switch, a lamp, fuse holder, a resistor to set the bias correctly, perhaps some bypass capacitors, output bleeder resistor, and finally the rectifier diodes. So these are the type of parts that you need to start collecting for the power supply. House the power supply into something. I've got this Bud AC405 chassis. This is plenty big enough to build a power supply for the 1155. The parts will easily fit on that. If you got some kind of a front panel, you could tack that on the front, and now you could mount the speaker on it. I'm very lazy. I don't like making holes in metal for speaker grills, so I took this material and just simply tacked some cheap paper like you put on the front of speakers on the front, and that'll go on the front of the chassis. If you really want to get fancy, you can put it inside some kind of old box like this, or this was very beautiful, by the way, this gold color. I don't know who came up with that scheme, but we'll be painting this with some kind of black wrinkle, and when the thing is done, we'll have a matching power supply for the receiver. So you always get some surprises when you're talking about power supplies, and I picked a transformer that looked right, but you really can't tell if the transformer's got the right windings just by looking at it. You actually have to measure them. This had come out of a school PA system, and it had 6-volt tubes, so I knew it had a good 6-volt winding. But the high voltage was a little higher than I expected. Instead of being 450 or even 500 center tapped, or something like reasonable, it was much higher. It was like 6 600 center tapped, maybe even a little higher. So I ended up having to use a choke input power supply, just like the old circuit shows here. Of course, without the drop of the tube, the voltage was soaring a little bit. I did not want to have to use two chokes, but I ended up having to use two in order to keep the voltage from soaring. And once you do that, you really need a bleeder resistor to make it all work right. So I ended up putting a 15K 25 watt resistor under the chassis as a bleeder, and that kept the power supply from soaring to a high voltage with no load. Next, you want to simulate the load, and 60 or 70 milliamps. I would estimate that we're talking about a 3,000 ohm load. So I've got these two resistors here that represent the load. And the first thing I wanted to measure was the no load voltage. I've got a small variac that's for a soldering iron, but it works perfect for this kind of purpose. That's fused at 1 amp. I also have a 1 amp fuse in the power supply. So let's go to voltage. Let's bring her up. Okay, it's coming up. Now this is going to be the no load voltage. Okay, so the no load voltage is 285 volts. Okay, that's before we have the load on it. So when we load it, ideally we'd like to have 220 volts, something like that. That's not great regulation, but I'm not going to put any stronger bleed resistor on there because I know that my load is fairly steady and the regulation should be okay. So the next thing we'll do is put a load on this. So first I'm going to turn it down. And the bleeder, of course, bleeds it off very quickly. And we're down to 2 volts already. So I'm going to hook it up. Okay, now we're going to bring it up under load. Ooh, isn't that sweet? 218 volts. Next thing we want to check is our bias at that level. Going to bring it down again. Don't like sticking my hands in things that are hot. Okay, so now we're going to go on the bias. Minus 21 volts. Okay, so a little bit low. There's a resistor under the chassis that will adjust and bring that up to minus 30 volts, which is what they're calling for. Looks like the power supply is going to work out just fine. Can you feel the tension? Particularly the high tension, because now we're going to start to work with some high voltage, and this is where some fellows run around with the hands in their pockets and stuff, One guy I knew, he always kept his right hand in his pocket, and another guy, he always kept his left hand in his pocket around high voltage. So these are, I don't know, which is better. But now that we have high voltages involved, we have to be a little more careful around the chassis. We've got an open chassis, and we've got 220 volts. Bad things could happen. Okay, let's do a quick high potential test. We've got our power supply now. I've got a variac on the power supply, no valves installed. Just looking at the B+, we're going to bring it up. So there's like 115 volts on the set. And just basically looking for the voltage to be steady, that there's not some capacitor that's shorted out or something rising where capacitors are forming or something like that. It looks steady. There we are, rated voltage 220 volts, and because there's no valves installed, the power supply actually will be much higher than that. I think we saw it would go up to about 280 volts unloaded, and essentially this is unloaded, so let's bring it up. Okay, so there's the full voltage, 271. That's a good test. These capacitors should all be able to work up above 400 or 500 volts, so putting 271 on is just a good checkout. I think we can put a valve in there. Let's start bringing it up. What valve shall we put in first? How about this 6V6? The last shall be first. And that's really a good way to go when you're talking about troubleshooting and signal tracing, which is what we're going to start doing. We're going to start with the output stage, get the 6V6 in, put a tone into it, see if that amplifier is working that we added. By the way, this is a particularly ugly 6V6. It's sort of like the leaning tower of 6V6. It seems to be sideways. Whoops! It seems to be sideways in its socket, and the whole thing seems to be kind of bent over. But it's a good candidate. We'll put that in. Very nice to see that 6V6 lit up. That's a good thing. We have to remember to plug in our speaker. But the first thing we're going to do is rig a way of getting a signal into the 6V6. And I think what we're going to do is use the plate of the preceding tube as the point that we're going to inject the signal. So here I've got some parts to make a signal injector. Basically, this is a probe that can be used either way. You can use it to pick up signals or to inject signals into your circuit. And all it is a probe with a little ground strap, a way to safely inject the signal through a 0.01 capacitor, and a little 1 meg resistor. And we'll build this circuit, and this can be attached to a generator or to a scope in order to either inject a signal or to look at a signal all along the way in the circuit. Just made from some simple RG58. And as you can see, we've got this is the Australian setup, because we actually have an alligator clip that's been replaced by a crocodile, and we have a banana. Well, here we go. And I wrapped some rubber tape around the interface where that thing popped out of the probe to give a little strain. So I had one poor guy comment that it had taken him several weeks to complete the probe, and that he was tired and really couldn't go on with the project. So I've attached the probe to my audio oscillator. I've got it set for 1000 hertz at, I don't know, about 150 millivolts. Sine wave. So now we're going to apply power. Let's bring this down so we can see what we're doing. Let's bring the juice up. Okay. I can hear a little bit of hum coming out of the speaker. That's always a good sign. And now let's try to get in on the 6V6. A little bit tough. That sounds pretty good. Okay, so our 6V6 stage we're going to call good. So the next valve we're going to insert is going to be V9, which is a VR101. It also could be a MHLD6 or a 6Q7G. And I recently found out that a 6R7G would also work. So We're starting to build up our knowledge of the tubes, and hopefully this guy will work. Power is off, of course. Don't go reaching into the set with the power on. Okay, so everything looks attached. Let's take a peek. We now have two valves inserted. We have the 6V6 and we have the 6Q7, or the VR101. And we'll bring up the power. Basically, we want to see if those are going to light. Looks like we've got some light showing. Yes, both valves are lit. And we're getting some hum. It's a good sign. Okay, since we're going through a second stage of audio, we need to lower our oscillator, our audio generator value 10 times. So we're going to go down to about 15 millivolts. Instead of 150 millivolts, we're going to use 15 millivolts. Right onto the grid cap of the 6Q7, I would say our system's working. Okay, working backwards. We're going to go to the second IF stage, and the second IF is a VR100, and we know that the VR100 is an IF type pentode, RF-IF pentode. Could be replaced by a KTW62, 6K7, a 6S7, or a 6U7. I've got a 6U7 here I'm going to try. Let's throw the 6U7 in. Get that grid cap on there. And we should be able to inject some RF at this point at 565 kilohertz. And if we had an AM modulated 560 kilohertz signal, it should be able to detect it. Okay, so we have fired up the RF generator. This old RF generator is going to be set for 560 kilohertz, 80% AM modulation with a 1000 hertz tone. We're going to bring that signal right to the grid cap of the VR101, and it should be detected and come through the audio system. Oscillator set up. We're going to inject a signal right into the grid cap. This is a 1000 hertz modulated tone. And now we've added the tube shield, and the shield will remain in place till we're done with the troubleshooting. Okay, we've added the next stage, a 6K7, and this stage is a V5. It's a second IF, and now we're going to be so sensitive we can probably put our finger on there and get some noise. So we're going to have to turn down our generator a little bit. .565. Okay, 565 looks like where the IF is centered. We're going to add the mixer stage in next. Actually, before we add the mixer stage, we need to put the BFO stage in. Let's see if that BFO works. Okay, again we're centered up on 563, 564. I'm going to turn off the modulation, turn on the BFO. Okay, we've just added the mixer tube, the frequency changer 6K8. Now, we can still do the IF through the 6K8's grid cap. Okay, so this is kind of the final check. Seems to be centered around 568. So the IF is definitely misaligned. We're going to have to go through the IF, but that can wait till later. Now we will put in the RF amplifier. Once all the valves are in, then we have to go back and check the bias level. We haven't touched that in the supply, and it's probably not right. So we need to go back and check the bias level. Yeah, it looks like we got 20 volts. We should have negative 30, right? But we got minus 20. So we need to bring that out a little bit. Ooh, that looks a little bit better. Settling in around minus 31. We're going to call that good enough. Okay, we made some progress with this thing. It's alive all right, and not perfect. We've got some issues. We haven't got the AGC figured out. We've got this raucous hum that we've got to take care of. But in the next video, we're going to take a little bit further. We're going to do the final alignment on the set after we get a few weaknesses of the set straightened out. We've got some hum we're going to take care of. We're going to get into tube substitution and specifically how to use miniature tubes in the receiver without ruining the receiver. So we got some real cleverness coming in the next video. But I want to let you know